Thank you, Richard. Yes, this morning I was going to talk to you about low impact development, the life cycle of that as a project, and put together. Well, we don't need to talk about me anymore, other than, as Richard said, I have been involved with water resources, stormwater projects for a long period of time, all over the country, actually some international work and so forth. So today we're going to talk about what is LID. I mean, there's a lot of confusion really about what it really entails, what it doesn't entail, what it does and what it doesn't do, why it's important, the life cycle of the project. Where do you go from the start to the beginning and to the end of it? And hopefully there's really no end. It goes on for a long period of time and serving its project purpose. And then some take-homes from that and any questions. And actually, if people have questions while I'm going through my presentation, don't hesitate to raise your hand and I'll try to answer them. What is LID? Well, you know, the initials of it are low impact development, but it really goes by a lot of different names. Green stormwater infrastructure, the green infrastructure, the environmental site design. So it's all lumped together under one general topic of low impact development, LIDs. Really the LID is, you know, it's comprehensive land planning, engineering to kind of take things back or keep things at pre-development levels. In the urban setting, you got more impervious area, you're going to have more runoff, you change the hydrologic cycle, and the whole concept is to control that runoff and keep it at the pre-development levels. Control it at its source, incorporating infiltration, retention, biofiltration. All of those concepts are to return it to the groundwater, to filter out undesirable materials, sediment, debris, what have you. The biofiltration is used vegetation to really to clean up that runoff that's generated. This slide you can see on your left there is the developed conditions. You know, you've got a minimal amount of evaporation, transpiration. There really isn't any vegetation to assimilate the water that runs off. If you've got impervious areas, you're not going to get much return to groundwater, and you're going to get a lot of runoff. Want to return it back to the lower right-hand side, they're the natural conditions, when you've got a lot of ET, much more ET, the infiltration allowing it to go back to groundwater, and really to reduce the surface runoff. There's a lot of components or examples of what LID can entail. You can have bioretention, bioswales, permeable pavement, the infiltration basins, vegetative buffers, sheet flow, let it spread across the landscape, storage and reuse, reforestation. Certain areas, this is a really good low impact development concept. I mean, you collect the rainfall as it falls to the ground. There's usually more debris on the land surface that will filter out that water. And in certain cases, that's very effective. Tree box filter, the last three there, the tree box filters, the rain gardens, and the green roofs are probably more towards the individual building or, even to, like a shopping center, things like that, or a strip mall location. But all the rest of them can be used in larger areas. The old versus the new, what is that? I mean, historically, we've managed stormwater. Stormwater is actually kind of a problem to everybody. It's a nuisance. You have to deal with it just because you do. It gets in your way sometimes. It can be detrimental to your activities, to your building, to your high. I mean, you know, with DOT operations, you want to get the water off of the pavement, off the street areas as quick as you can, so it doesn't interrupt traffic or is a dangerous condition. You know, most of it is generally regulatory driven, but with the LID, it's a better way of doing things. It's a more natural way of doing things. It's not hard engineering, you know, you're not out there, you know, building retention basins with overflow weirs and what have you. You know, it's soft. It's soft green engineering activities. Okay, the life cycle, it goes through, looks like a long list here, A through I. But you know, you start out with the planning, you've got design, there's specifications that are necessary. In certain instances, there's a lot of individual LID type projects that just go from the concept to the contractor that can actually just build it. Some Hawaii considerations, talk about construction itself. There's inspections during construction, you get startup and maintenance and getting the things up and going and everything. Long-term O&M, and finally, after it's all done, to make sure that it's still functioning going into the future. And that's where we get into the post-construction inspections. Planning, I call that a three-step process. You got to kind of look out where you're going to do this, lay out the site, and plan for what it is. Select your LID practice. Is it going to be bioswales? Is it going to be bioretention? Or one of the other aspects of LID. Bioswales work real good. They're actually kind of like speed bumps. They work. You can work in your ditch areas or grass waterways and so forth. They're very, very effective. The next part in the step 2 is check on the runoff reduction, because that's the whole thing you want to do here. Is when you've got impervious areas, you're going to have increased runoff. You want to control that runoff, and so where's it go? How effective is your particular LID to reducing that runoff amount? And then based on that, what is the size that you need to do? There's a lot of information out there. I mean, if you do a Google search on the letters LID, you get a lot of information. There's a lot of good. Municipalities all over the country. There's a LID center on the East Coast that's been in business. In fact, I think Neil was here, spoke to this, wasn't it, Richard, last year? Weinstein from the LID center. But just a lot of good information on design procedures, hydrology considerations, what have you. And then you initiate the design. The design you get into, you want to really achieve multiple objectives. You want to, if there's natural features and resources, you want to preserve those. You want to take those into account of what you're doing, what you're trying to plan around, and so forth. One of the big considerations for LID, because of the infiltration consideration and so forth, you want to minimize soil compaction. Through your design and ultimately into your construction. And keep that stormwater close to where it fell on the ground, on the land surface. You don't want to go and have, pick it up at the end of the pipe or something like that. It's much more effective to do it right there where it falls. And the last one is to reduce and disconnect impervious areas. You don't want to have, large areas of impervious material. That increases the runoff. It's more that you got to contend with. Have smaller zones of that and what have you. Some specifications. I pulled these out of the Hawaii DOT, and I'm pretty sure this would be the pretty encompassing list of what specifications generally would apply. I mean, I've been involved with, there's different formats of specifications. Departments of Transportation usually use an AASHTO format of specifications, and this Division 100, 200 series follows that. There's other specifications, the Construction Specification Institute CSI format. They have some of the similar sections of specifications. For the most part, these specifications can be utilized generally as is, or maybe some general information provided for like what the scope of the project is, or the project summary section of it, the earthwork. It might, there just might be some minor language, but you can follow the general format of those specifications. I've been involved in projects, like I said, across the country, and that we've utilized the highway specifications for LID construction, and quite successfully. So I've got, there's the general provisions. There's always going to be earthwork, miscellaneous construction, and the materials section of it, because you're going to, you want, materials section includes both, granular base material, as well as for filtration, as well as the planning section. Also, getting into the Hawaii considerations with the stormwater permits for construction. I mean, the size, it depends on the size of that particular LID. It may or may not apply, but it may at least apply under the general permit considerations. Got the construction stormwater permits, the notice of intent, a SWIP that's necessary, BMP installation, and so forth. Inspections and monitoring during the time that you're constructing that. The actual construction, you want to, where's the LID going to go? You want to lay it out. You want to identify and locate any BMPs that would be associated with it. Again, that limiting the traffic over the LID is important. You don't want to be compacting that soil. You want it so that you can get percolation and infiltration when the LID is constructed. Got here, use the low ground pressure track. This means the wider tracked excavating equipment. You may have to use the long reach excavators in some case, which is just a special case of the low pressure equipment. And scarify or rip the bottom to increase the ability to infiltrate. It's a construction checklist that I found for the LID. This was one that was developed, or at the time it was published, it was under development, but now it's in use for the city of Fort Collins, Colorado. Goes through when you lay out what activity was taking place. Heavy equipment was the bottom of the cell scarified or ripped, what have you. Photographs. I mean, this is typical of any construction inspection. You want to take photographs. You want to document what was done and who was there, and if there was any incident that took place. Startup and maintenance. Chances are, during the time or shortly thereafter, you're going to get a rainfall event. And likely you're going to get sediment, trash, other debris that will wash into your LID. And that's things you've got to deal with. You've got to provide maintenance for that, remove it, get it out of there. And a part of your design, you would probably have some type of screen or something to, to accumulate that. It's another good reason for incorporating the bioswales, because the speed bumps act to allow you to collect not only the sediment, but any debris or trash that might be flowing in. The soil pH is necessary to look for the establishment to ensure the establishment of vegetation. You want to make sure that unvegetated areas, that you can cultivate those and replant them if necessary, because vegetation is a key to these LIDs. And like the last one there, ensure that there is vigorous and healthy growth of grass or what other vegetation that is a part of the LID process. Long term, that same consideration. You want to look at, you've got to deal with the sediment, trash, and debris. That is probably the biggest complaint on having LIDs in the long-term sense, because they do collect sediment, they collect trash and what have you. But at least, well, all of these are part of your overall general stormwater management process. You've got that as a problem anyway. And in some cases, it does become a more concentrated or identifiable area to collect them and everything. But it does take maintenance to remove that material. Sediment, debris, and trash that will accumulate, you've got to remove it for the system to continue to be effective. One of the problems, if you're building these, either along the road right away or in a little bit more remote or limited access areas, it can be difficult to get to them. But that's one of those things you need to kind of plan on up front and in the planning process to incorporate in your design. Some of the maintenance problems that can occur with LIDs, they generally go back to they're not performed frequently enough. You let it get up to a state where you've got a problem. It's filled up with sediment. If it's filled with sediment, it's not going to retain any water. It's not going to allow infiltration and so forth. It just plain isn't going to work. All you've got is an ugly spot out there in the countryside or along the roadway or in a parking lot, what have you. Costs need to be considered in annual budgets. This is one of those things that's kind of this is a hard one because, while LIDs may sound, they've been, 15, 20 years, 15 years for sure, because I know personally I've been involved with them for 15 years. But the costs are just kind of starting to come together. I've seen costs going back 10 years ago starting to get some costs developed. We know what standard cost, for like excavation and reseeding and things like that could be from, experience. But there's a lot of information, again, by doing this Google search of entities that are doing this. With the U.S., LIDs are applied everywhere. The mainland, I don't think there's a state that doesn't haven't applied them. They're doing them in Alaska. I've had personal experience with using LIDs in Alaska, which gets a little bit interesting with the permafrost considerations and so forth. Here on the islands, and this actually is probably a location with the the ability to promote the growth of vegetation is very good. So there's a lot of information. There's a lot of experience out there, and if you're starting out and looking for something to get a handle on what it could cost to maintain these, you can find that information. And last, it just wasn't done right. I really don't know what that problem could be, because you're going out there, unless you get into that you're recompacting the soils or doing something like that. If you just go back to what the original plan was for the construction of it, and that's what you maintain back to, you should be able to achieve it. Some of the post-construction, again, it goes back, that you want to have certain routine inspections, periodic, that are done just to make sure everything's good. Are you getting accumulation of trash, a lot of sediment, what have you? Is it looking nice? Because that's a key aspect of it. It can be a very aesthetic system if it's operated correctly. It could also look like, something pretty trashy and junky if you don't. And, select the wrong type of vegetation and so forth. Then you get into, the as needed. If you get a major stormwater or runoff event, these systems are not designed for the 25, 50, 100 year, or, I don't even want to think a 500-year event, because they probably won't survive. And that's okay, because they're not intended to do that. They're not a flood control project, they're a stormwater project. They're for those more routine runoff events to control sediment and debris and promote infiltration. But when you have that large runoff event, they need to be inspected and any appropriate maintenance at that time. Some other resources and take-homes from this. Learn what you know and know when you don't know it, so you can ask questions. And again, there's a lot of people out there that can provide insight and support to assist in the design, the construction, the operation, and so forth for LIDs. Here in the state, we've got, there's a construction BMP manual, a maintenance BMP manual, and the permanent BMP manual that are available out there to assist in this aspect. And I think I got really kind of fast on this, didn't I, Richard? Hopefully, it is a topic. There's a lot of things to consider, but it's also kind of, it's straightforward. It makes common sense. It's collect and store that runoff at the point of application, where it falls on the landscape, and there's a lot of different ways that you can make that happen.